Welcome to solverfy.
Thrown with initial velocity and initial angle, and it hits the wall when it has only horizontal component of the velocity. So if in this point it has only horizontal component of the velocity, means that vertical component of the velocity is 0, and then this point A is the maximum of the parabolic trajectory of the ball. So now we have to introduce y and x axis, and let's project v0 onto this axis. So v0x equals to v0 cosine alpha, v0y equals to v0 sine alpha. Cool. Now let's write down vx as a function of time, so that's constant because there are no horizontal forces, and vy as a function of time is v0 sine alpha minus gt, because there is only gravity exerting in the vertical direction. At point A, v0 is 0. Then, so vy is 0. Then v0 times sine alpha equals to gt. Okay, let's label it as t total because it's time of the flight. Actually, yeah, we can just label as tf. So that will serve for equation 1. Now we can express h as a function of these parameters. So as we know, h equals to v0y squared over 2g, because final velocity, because the velocity at point h is 0, I mean the vertical component of the velocity. So therefore it's v0 sine alpha squared over 2g. Okay, and now we need to express L as a function of v0 and alpha. L equals to v0x times time of flight, or v0 cosine alpha times v0 sine alpha over g, or it equals to v0 squared sine alpha cosine alpha over g. Okay, let's write down the system of two equations now. The first equation is h equals to v0 sine alpha all squared over 2g. And the second equation is L equals to v0 squared sine alpha cosine alpha over g. Okay, let's simplify the first equation. It becomes v0 squared times sine squared alpha over 2g. Okay, and in the second equation, we have that v0 squared over g equal times sine alpha times cosine alpha. So what do we have? Yeah, let's express v0 over g from the second equation, and then substitute it in the first. So because here we likely need to solve the trigonometric equation, and yeah, we'll just try to optimize it. So from the second equation, v0 squared over g equals to L over sine alpha cosine alpha. Now let's substitute it let's substitute this guy with this expression. So then h h equals to sine squared alpha over 2, right, multiplied by v0 squared over g, which is L over sine alpha cosine alpha. Oh, that's great. Now we can get rid of sine alpha in denominator, and in numerator we just have sine alpha. So therefore this equation is L over 2 times sine alpha over cosine alpha, which is L over 2 times tangent alpha. Now we can calculate tangent alpha. Tangent alpha is 2h over L. Then alpha is a tangent of 2h over L, or a tangent of 2 times 13 over 11. Let's calculate it. Now we are close to solve half of the problem. It equals to 67.0 degree. Now we just need to calculate the velocity. And here we can just use one of those equations. Let's see what works, what looks better. Let's use the first equation. So h equals to v0 squared, v0 sine alpha all squared divided by 2g. Then v0 sine alpha equals to the square root of 2gh, and then v0 equals to the square root of 2gh over sine alpha. Here it's 2 times 9.80 meters per second squared times h, which is 13 meters, and is divided by sine of 67 degree. Okay, now let's calculate this number. It equals to 17.3 meters per second. So here is the solution of this problem. That is the initial velocity. This is the angle. I hope I helped you. Thank you very much for your attention.